All right, good morning. How you guys doing? Scared about the exams? How did you guys feel? Not so good. Um, just looking, I've graded most of the first page for everybody, and I recognize that the chemistry apparently was a little trickier than I guess I had hoped it would be for you. So I haven't looked at the rest of it yet, even though I did get started on it. So don't think I'll have them ready for you on Thursday, but probably next week for the grades there. Okay, today we're going to talk about the Flint water crisis. I just wanted to touch base real quick. We sort of have a couple of topical lectures. Next time we might go a little quickly through this and get into wastewater microbiology, but essentially I'm going to give you the Flint water crisis kind of a lecture seminar today. From there, we're going into wastewater, so we want to cover a bit of the regulatory framework, why we care, and kind of how do we arrange our treatment according to what we need to accomplish in terms of wastewater, and then really get into the core processes there from a sort of taking a look at the mass balance of the biological systems. So if you're tracking in this sort of a way, we've kind of covered physical processes with a bit of chemistry, then chemical processes. I guess UV is somewhere between physics and chemistry. And then now it'll be biological processes supported by the chemistry and the physics, I guess. Okay, so that's kind of where we're at. We've got Thanksgiving break coming up soon. And yeah. So today, I want to tell you about the Flint water crisis. So how many of you kind of have a good feeling for what it's about? Lead in the water, right? Kind of have some knowledge. Do you ever hear about the Legionnaire's disease outbreak as part of that? Probably not. Right, that actually killed people. So we'll talk about that. It was related. Didn't quite make the news as much, and in part because it was generally pneumonia. It's pneumonia, and the people that it really harmed were people that were already probably on their deathbed. But it would have been the thing that pushed them over the edge, I suppose. Okay, so there's actually, in that sense, crises, right? There's lead in the drinking water, this Legionnaire's outbreak, and there's also a couple of other things that happened along the way, specifically related to the water treatment system. There were a couple cases where there was a lot of bacteria. Bacterial counts were too high as water was being distributed to Flint residents. So that would trigger boil water advisories, which you really, you kind of understand that occasionally that happens in real life, but when it's coming from the treatment facility itself, that's pretty bad news. Like it's not too uncommon to have a water main break, so you lose your pressure, you have potential for infiltration, so you'll issue a boil water advisory. But if they're coming from failures at the treatment plant level, that's bad. Likewise, they also had disinfection byproduct issues we'll talk about. I posted some reading materials on the Flint water crisis, two articles and a video lecture if you're interested from a professor at Virginia Tech, Mark Edwards. He was very helpful in confirming and identifying that there was lead in the water. We'll talk a little more about that, but he has a very interesting perspective. He goes through a lot more about the EPA's lack of involvement or failures to be involved at first. So he has some pretty intense things to say about that. So he has definitely a different edge to this than I can give. But there's also two articles that are Good articles. I would encourage you to take a look, meaning maybe read the abstracts, take a look at their conclusions, skim through the graphs that they have to kind of see what they were doing, what they were up to, and see if you can get a basic understanding of what these papers are about. Okay, they're scientific journals. I don't expect any of you to go through and master it and know every last detail about what they're doing, right? But if you get a big picture overview of kind of what they're about, how they approached it, I think that would be a good thing. So maybe 5-10 minutes on each. Okay, a little context here. I actually lived in Michigan for 2 years, 2014 through 2016, before starting my job here. And so for part of the Flint water crisis, I was living right here. And so for a little bit, I worked at Michigan's Department of Environmental Quality. Fortunately, I was dealing with wastewater permitting, so that'll be a next lecture's topic, drawing some experience from there. But I was around some of the stuff that was happening, and at the time, my wife was doing a fellowship with Michigan's health department, so she was involved in part with the Legionnaires outbreak stuff. Flint, Michigan is the dot highlighted here. So it was about an 1.5-hour drive from Lansing. It's the capital, that's where I was living. So have some interesting perspectives to share with you, I would say. All right, and the way I'm gonna do that is kind of walk through a timeline to kind of tell the story of the Flint water crisis, of kind of how this came to be and why we had the issues that we had. Pardon me a moment, I need to fix something. Move the webcam, okay. All right, so the basic starting point is we used to use lead in our pipes, right? And we don't really do that much anymore. If anything, sometimes we'll use galvanized steel in some plumbing, which does have some lead in that process, but I think more and more we are just trying to avoid it altogether. But it used to be the case that you'd at least do the soldering, if not the actual pipes themselves, with lead, and we just didn't really know the risks there. So for a long time, lead pipes were used quite commonly. In fact, if you recognize on the periodic table the abbreviation for lead as PB, that's essentially coming from Latin, and it's the same root that we get plumber, right? The PB in plumber, it's the same, kind of the same source. So it's been used for many years in pipes. Some suggest that maybe some of the Roman Empire's issues were from the lead in the lead in the plumbing. Now, it actually should not be an issue so long as proper corrosion control is being used. So if we think about equilibrium chemistry, we've talked a bit about, precipitation reactions are just that, an equilibrium reaction. So if you keep the water in such a way where rather than lead coming off, going from the solid form into dissolved form, if you force it in the other direction, so it's always wanting to precipitate, then you should be good, right? It can stay there. You can actually get accumulations of mineral deposits, all, kind of almost constricting the pipe rather than eroding the pipe. So if you have over a long amount of time slow constriction of these pipes, slow mineral buildups, you're actually protecting the water from whatever the pipe was made of in the first place. So what we do by design is we operate our distribution systems in a manner that is controlled for corrosivity. We call it corrosion control, and it's as simple as phosphate. Just add a little bit of phosphate buffer or orthophosphate. And that keeps the pH under control. It helps push the lead chemistry to be stable. And so what we'll see is a lot of the Flint water crisis really was an issue of corrosion control failure. So theoretically, it's fine to have lead pipes so long as we're operating correctly and we don't have anything that's causing them to flake off, or to, if we had some mechanical thing happen that shook some of the pipes, you might have lead particles come into the water, which would also be a problem, right? So maybe things like earthquakes could be a problem. Okay, at any rate, in the 1900s, we put in a lot of infrastructure. That's kind of around the time we were doing all that, roughly. Then in 1930s through the 1960s, we had a very large auto industry boom. It was manufacturing towns all over the north. What we now might call the Rust Belt used to be a very thriving auto industry, lots of steel mills, lots of people engaged in productive work there. So in that era, Flint as a city and many others around it grew really large. In fact, so much so that after that time in the 60s and on, as it collapsed, and for whatever reasons, we could think about, what caused that and try to ascribe some blame there. It's not really what we're about, but, whatever the decisions, policies, economics that caused auto manufacturing to move out, I think a lot of it probably went overseas. Ultimately, whatever the case, there was a localized economic depression in Flint. So you had a large population there relying on the industry, and it's another aspect of that. If we're thinking about how not to let this happen, well, how do you take a town that is supported by one particular industry and diversify it? Right, might be a good question. We're not here to do urban planning or any of that, but it's just things to think about a little bit. So at that point, Flint as a city just was declining. Right, no more jobs means a lot of people that could afford to move away would probably move away. People remaining probably didn't have nearly as many opportunities in terms of jobs around to support the people that were working in the factories. Right, so whatever the case, there's a lot of people now in a very difficult spot, and the city itself is in a difficult spot with a lot less revenue tax-wise to support the infrastructure that was designed for a lot more people. So when you had, for example, water, but also the roadways and things, you had kind of an amount of infrastructure that you now need to maintain that was built for, I don't know, let's say 400,000 people, but now you have 200,000 people. Then that tax burden is more severe, and it's covered by fewer people earning less money, right? So it's a very difficult context there for the residents to deal with. By the early 2000s, the state was recognizing, so the state of Michigan's really in this entire Rust Belt regions. A lot of cities there hurting, Detroit, Flint, surrounding areas. For a while, they had been doing a revenue sharing program to help these cities that were struggling so badly. Some cities up there were doing all right. Grand Rapids, for example, has tended to do okay. Maybe it was less industry heavy. And at some point, they decided to stop sharing revenue between cities. And just thinking about it practically, there's something to be said for oh gosh, why would they stop doing that? How could they do that to the people in need, right? But there's also an aspect of, well, if you're living somewhere and paying taxes, presumably to have some benefit, now that money is being taken and being sent elsewhere. That doesn't feel so good, right? And there's something to be said for for both sides of that. So I think that at minimum, we can understand there's a conflict, right? People want to be treated fairly, and people want to get help when they need help, right? And that's part of what we look to the government systems to do. So whatever the case, however right or wrong that might have been, that's what the state decided to do. And so at that point, there's Flint is one of these cities that was relying on shared revenue. And at that point, they're going to be in big trouble because they, like we said, they have a very severe economic depression locally there. So in 2011, the city of Flint is basically going bankrupt, and so the state government appoints what we call emergency managers to step in and to presumably make the hard decisions that they think that apparently the current elected officials, the mayor, whoever else, are apparently incapable of making. So basically, we have a small bit of tyranny, right? Unelected officials making decisions on your behalf and telling you what to do, kind of thing. In a way that, somebody has to manage it in a way that can be financially feasible. That aim makes sense, but as we'll see, the scheme here really did quite a lot of harm. Okay, so emergency managers being in place starting in 2011, and these would be annual appointments where it would be some official, maybe somebody with some business experience, maybe somebody with law experience, who knows. Whoever the governor thinks is qualified is appointed. So these are yearly appointed officials, and these will rotate. Sometimes the same person will be there for a couple of years, sometimes somebody else will be there, and they're not necessarily local to Flint. So the context here is, big state government's coming in and telling us what to do, kind of thing. There's a lot of sentiment in that manner. I'll explain a little more of that in the health department situation a little later. So in 2013, the emergency manager of the time decides that, hey, maybe it would be a good idea to stop paying Detroit so much for the water that we're drinking, because conventionally the city of Flint was purchasing water from Detroit. It was piped up 80 miles or so to the city of Flint, and they had a small treatment plant that could up the chlorination and send it out into the distribution system. But the water itself was pretty good coming from Detroit. And if we were to flip back to the slide, the picture of Michigan, you would see it this way, I guess. Detroit had been getting their water, I think, from Lake Huron, or it's the river between the lakes there. But Flint decided, hey, well, we could join Saginaw. I'm going to flip back here. We'll come back. Essentially, Flint was saying, hey, we could get our water from here. There's another city right about here that was going to build an intake, and they could kind of add on to that, because typically Detroit was getting their water from here, and then it was piped up to Flint. In the meantime, though, when Detroit heard about this, or the Detroit Water and Sewerage Board, they were a little upset to hear that their long-paying customer, was just going to sneakily, jump ship. I guess they hadn't talked with Detroit, and so Detroit Water and Sewerage were in some way angry and gave them a 1-year termination notice of their contract. So, well, if you're going to just jump ship on us without talking to us, all right, you have 1 year. We're going to terminate. So, as we'll see, that caused some problems, and you might point a finger at the Detroit Water and Sewerage Department for doing that, but at least we'll see they somewhat redeemed themselves from that. So that gives Flint 1 year to change water sources, which is not a lot of time, especially when they hadn't formally put in all their plans and begun, they haven't broken ground on anything like that. So they realize they're in a pretty tricky situation, and their original plans are going to take too long. And by the way, their original plans, I think it was something like to save $5 million over the course of several years or something. So, some savings. I'm going to say $5 million over 5 years, something like that. I don't have the numbers exact here, but we'll compare to that to see how much they were spending on the renovations. So they could save some money if they treated it themselves. They thought that they probably could, but with 1 year's notice, they needed an alternate. So in April 2014, and just to give you a bit of a timeline here, at this point, I'm still living in Atlanta in grad school, but I am defending my thesis pretty soon around that area, maybe a month or so later. Flint decides to use the Flint River. So the Flint River is known locally for being an old dump site for a lot of industrial junk, waste stuff. So the residents have a pretty poor view of it and the water quality. And if you're not careful, you could kick up some sediment and probably get some nasty stuff. So perhaps rightly so. At the face of it, though, it should be able to be treated and be a fine source, right? Realistically, that should be possible. But there's going to be a lot of public perception there to say, ew, why would you ever drink from that, right? Maybe, I don't know, maybe you could think of the LSU lakes or something as a lot of people would be grossed out, right? Okay, so when they make that switch in April, and that's really what we would say is the starting of the Flint water crisis. Issue largely being the fact that they did not add corrosion control to this water, and it just so happens that the Flint River is naturally more corrosive. pH was probably a little different. Just the constituents, the alkalinity, for example, more corrosive conditions than the water that they had been receiving from Detroit. So suddenly, what's coming out of the treatment plant looks fine, tests fine, there's no lead in that. But what's coming out of the taps later is going to be influenced by this change. Since we did have anti-corrosive, so non-corrosive water previously, and suddenly we're starting to introduce corrosivity, that's going to make an impact. So essentially immediately, the Flint residents start to complain about the water quality. The color changes a bit. It might probably tastes a little worse. And you probably would expect this if you're a public official. You probably expect that to happen regardless. People don't like change. If there's any controversy involved, they're especially not going to like the change. And as we talked about at the start of our section on drinking water treatment, aesthetic problems are just that. They're aesthetic, so they're not actually enforceable. So if the water is treated sufficiently and the tests are coming out fine, presumably it's safe, right? But in this case, the residents were rightly concerned. The city officials, whoever was in charge of the design for the treatment, really missed a massive thing by not noticing the need for corrosion control, or not accounting for that. So there was definitely an issue there. By August 2014, there were high coliform counts, so that means bacteria counts in the water. August is the hottest month up there. It doesn't get all that hot, but it's warm and there's more bacteria in the water. And the plant that they did have was actually a bit under capacity. So it was not designed with sufficient capacity to treat the water that they needed to and give it proper disinfection. So they ended up having to do 2 different boil water advisories. Their solution to that, in addition to announcing, hey, boil your water, was to start using a little extra chlorine. But like I said, they didn't have quite enough treatment capacity. So what happens is, given that they have some organics in the water, they start forming a bunch of disinfection byproducts. So then as they're monitoring for trihalomethanes, they get in trouble for counts that are too high, over the threshold. So now they are having to scale back their chlorination. So they're really kind of stuck between a rock and a hard place here. What they really needed to do was to either increase the size of their chlorine contactor so they could use less chlorine and give it a little more time, or perhaps add something like a carbon filtration to remove some of the organics so that they are they don't have such a severe case of disinfection byproducts if they do use a lot of chlorine. So there's several solutions that could be taken there. They just weren't equipped with it. So they're having to do quite a few upgrades. That same month, there are city officials working in Flint telling the residents that the water is safe. Meanwhile, literally having trucks of bottled water delivered to their office so that they don't have to drink the tap water. So the hypocrisy is palpable. It's there, right? It's pretty bad. By this point, by December, and again, as a point of reference, most of the public had no idea that there was something going on here, myself included. I moved to Michigan, got married and moved in October. And then I was unemployed for a few months, getting married and all that. And then it was early January, early 2015, probably January, February, where I started at DEQ. Okay, so they had spent $4 million on just water treatment plant upgrades for the sake of treating the Flint water. So their target of saving, I'm pretty sure there was a figure of $5 million over some amount of years, is pretty much already down the drain. They're already spending a lot more than they should have on this type of a project. So that's a big deal. Their emergency manager is making poor decisions and poorly implementing all these things. Okay, so in January 2015, Detroit Water and Sewerage recognizes, even before anything was known about the lead, because at this point nobody knows there's a lead issue, a corrosion issue, any of that. Just people know that there's a lot of people complaining about the water, and there's a lot of coverage about that, a lot of contention about it. So in January, the Detroit Water and Sewerage Department offers to reconnect, to kind of bail Flint out here. And importantly, they also offer to waive the fee. Now, this might sound like, oh, good, they don't have to pay $100 for the fee, whatever, right? This is going to include the costs for engineering plans, excavation, whatever needs to be done to adapt the water system to go back to how they had it where they were supplying water. So this is not some trivial fee. This is actually a big deal. This is a lot of money. So this would be engineering, probably all the regulatory issues, and whatever construction required. Might not be massive, but certainly there's going to be some stuff there. So this is actually a pretty substantial offer, right? They're actually when I said they kind of redeemed themselves, you know, they recognized Flint was in trouble. I'm sure they want their business, but it was not like not something they were obligated to do in any manner. However, the emergency manager rejects that and says, "No, we don't need that." There's something to be said for propagation of error. Is that when you describe, like, maybe you're betting on something, like playing poker or something, and it's not looking good, but you already invested some, so you keep going, just propagating your error further, wishing it would change, hoping you don't lose, and it just gets worse and worse, right? So decidedly in a continuing in the bad decision making here. By March 2015, the City Council votes unanimously to reconnect to Detroit's Water and Sewerage Department. Unfortunately, their ability to self-govern was taken over by the tyrannical emergency managers. So that was vetoed. And I say that in jest, but that's kind of serious, actually. There's literal lead poisoning happening right here, and somebody that thinks he can make good decisions is doing the opposite. So soon after is when people started noticing the lead problems. And the real sad part about this is what it took was for pediatricians to find elevated lead in children's blood. So lead poisoning and lead exposure is essentially equivalent to permanent brain damage. So by the time you're finding it in children's blood, you've had permanent harm, right? These children are going to be affected for life by that exposure. And as the pediatricians were, one in particular was somewhat of a hero, and really wanted to find a way to say, where is this coming from? All of this controversy with the Flint River water, all of this stuff. Everybody thinks it's got to be the water. How can we prove that? And so that's who got in contact with Mark Edwards, the professor at Virginia Tech, and he was able to. He'd worked with a similar issue with DC some years back, and was able to essentially bring capacity to do testing in the appropriate manners with appropriate protection and caution and care, and enable some locals to participate in that to test the water. Okay, by October 2015, Flint switches back to the Detroit Water and Sewerage Department's water that immediately supplies the system with corrosion control. And so here's where you might say, okay, at this point, the Flint water crisis has been solved or fixed, right? Clearly, there's a lot more still going on, but at least that would be the end point of when lead was actively being stripped off the pipes and entering. Now, it'd probably be a little bit longer before lead was truly flushed from the system. Ongoing efforts have been made to try to replace all of the lead pipes, and understandably so, especially for the public perception. It's going to be a little bit difficult to tell everybody that you were the distrust here is pretty important, because the city officials were saying, no, it's safe to drink. We're not going to drink it, but you should drink it. And then it wasn't safe to drink, right? And then to say, okay, well, we didn't change the pipes, but it's safe to drink now. It's kind of understandable you're going to have some outrage, and you probably need to do more of that, even though from a technical aspect, there's lead pipes everywhere. And with proper corrosion control, we don't have lead poisoning everywhere, right? So that's a little bit of a mixed bag, where our technical knowledge comes up against the sort of what's needed for society and for the social aspects is probably a bit different. January 2016, the governor finally admits there's a Legionnaire's disease outbreak that the health department knew about since 2014. We'll talk more about that. But finally, after the this piece of after the lead part was mostly solved, they finally get around to admitting that okay, maybe there's some other problem here too. As you noticed, most people hadn't heard of it. So we'll talk a bit more about that. And then it wasn't until February 2017 when the CDC was finally able to link the Flint River water to this Legionnaire's disease outbreak. It turns out that my wife, working as this fellow just out of school, back in 2015, probably the summer of 2015, was literally in correspondence trying to get the Genesee County, was the county that Flint is located in, trying to get their health department to take proper surveys of, okay, if you have Legionnaire's disease, then they follow up with a survey, and they were trying to get the health department to say, okay, construct the survey this way so we can get the key data that we need. Were you on Flint River? Were you not? And to collect DNA samples for matching. But as part of all this distrust, for some reason, the officials in the Genesee County's health department really did not want anything to do with the state health department and were just not complying. So they did not collect their DNA samples to match. So it actually took quite some time before the CDC was able to make that confirmation there. We'll come back to that. Okay, so last time I really checked and dug into it, I mean, I took a look again this time, but the most recent legal updates in 2021, former Governor Rick Snyder and 8 officials were charged with combined 34 felonies, not each of them individually, but in total, a couple misdemeanors. 2 of the officials were charged with involuntary manslaughter. I don't know if those anything more became of those or not. Charging does not mean they were convicted. But the legal outfall from all this is continues. So lots of bad stuff happened. People died. People were poisoned for life, and a lot of that could have been prevented with simply corrosion control. There would still have been some other problems. There definitely would have been the disinfection issues, which probably relate to the people dying from the Legionnaire's disease. So we'll talk more about that in just a couple minutes. But the permanent brain damage, lead poisoning, certainly could have been solved with proper corrosion control. So there's several things there, and my overall impression is there were some very bad dynamics all over the place, with top-down decisions being made, perhaps either intentionally overruling somebody at kind of the mid-level that I'm not aware of anybody saying that there should be corrosion control, but they should not have authorized the Flint treatment plant to do what they asked it to do. And I think there was some, just capacity-wise, and I think there was some overruling by the emergency manager to say, no, you guys have to do that, make it work, kind of a thing. At least I saw some of that with the Legionnaire's disease outbreak. Okay, so bit of an overview here. What were the failures? The corrosion control, well, really lack thereof. You can see the different colored tap water here. Same tap before and after the switch from Flint River back to the Detroit Water and Sewerage Department water. Clearly visible why people would not be interested in drinking or even bathing in that one on the left, that was actually a part of the issue too. There was a bit of a outbreak of rashes because some people were worried that the water itself was giving rashes. Some people were just not bathing enough and therefore getting rashes. So there's some issues there as well. Okay, corrosion control, inadequate treatment capacity, therefore excessive chlorination, And what do you know? Chlorine is also corrosive. So, if they're not dechlorinating properly, I'm not sure, but could have also led to more corrosive water. Another thing that I didn't mention yet directly is, as we think about the amount of people that used to be in Flint, and perhaps half the population or more moved away at some point, you end up with a situation with a lot of vacant homes. And that tends to cause the water's age in the pipes to be not ideal. So there's a lot of areas in your distribution system where normally we kind of try to design with some maximum water age. We don't want water sitting in the pipes for longer than a few days, because then the chlorine will decay. We just get issues with stagnant water, right? Maybe bacteria, naturally occurring bacteria like Legionella could start growing, for example. And so this is outside of just the Flint water crisis. That's a common issue, but once you introduce a new water source and it's not disinfected as well, there is a high likelihood that is part of what contributed to this Legionnaire's disease outbreak, is the fact that there was new bacteria introduced and a lot of time for these bacteria to just kind of sit there and potentially grow. Another issue was that the lead and copper rule, the way it was written and implemented at the time, failed to catch the issue of water coming out of the taps. So I have a little bit of a description on what the lead and copper rule, it's been going on through revisions accordingly. So at its base, what the lead and copper rule is supposed to do is catch issues like this, where you have lead and or copper coming out of water at levels that are not safe. Now, basically any lead is not safe. But what we have in the lead and copper rule is what you do is you sample a certain number of taps, and these have to be of certain types, right? Maybe a couple have to be in a restaurant. Most of them have to be in homes. Things like that. There's a few rules, and you take, historically what you do is you take some number of them and you discard any statistical anomalies. So you might take samples over 80 or something things, and it's done semi-annually. And if there's one particular spot, by convention, by the method, you are supposed to discard certain anomalies. Now that ends up sounding very controversial, especially in a case where that might be part of the reason why things were missed. So there was a bunch of controversy. I actually don't know enough about the exact details of how that controversy played out. Were people doing it wrong? Was it just people thought that they were doing it wrong because of because they were following the EPA's guidance on how to identify an anomaly and discard it? You could easily see how people might ascribe malice to somebody discarding lead data during a lead crisis, right? So whatever the case, there's certainly been some revisions going on. So this lead and copper rule, we treat it as an action level. The technical way to describe this, 90th percentile of samples must be below 15 parts per billion of lead and 1.3 parts per million copper. Otherwise, some action is triggered, right? So that 90th percentile is where you're discarding the 10th percentile kind of thing. Okay, so then there's also a bit of subjectivity potentially about the site selection, so the likelihood for impact. So there's potential for some controversy there. It was originally issued in 1991. There were some revisions. This lead and copper rule revisions were issued in 2021. These are aiming towards replacing the original, updating it, and they're on their way to doing so. Okay, so it's not quite fully implemented yet. And there was some previous rules about replacing 7% of leaded containing pipes every year, but there was a whole bunch of exceptions where, okay, if it was such and such a case, if you don't have the blueprints, if whatever, there were a lot of exemptions available. So that's going to be replaced with 3% of existing lead containing pipes, but pretty much no exemptions anymore. So in essence, there will be much more replacements happening under the new rule. They were tasked with, the EPA was tasking themselves, I guess, with reviewing and adapting the lead and copper monitoring protocols. So these protocols where you have to say, okay, here's the likely sites, let's monitor those. It also included a big portion of corrosion control education for operators, for anybody dealing with the water distribution system. And then there was a few things that are scheduled to be formally in place as required by October 2024. And that would be establishing lead service line inventories. So we actually know where the lead is. That was a big problem with Flint, is when they started to try to replace them, they didn't even know where they were. I think they actually used some machine learning algorithms to ultimately to help identify where it was likely that pipes would be. But especially on premise plumbing, houses built maybe in the 1920s or 30s or something, who knows where the pipes are, right? It's pretty difficult in some situations. And then another key aspect was to improve customer contact and communication protocols. So how does the water utility get in touch with their customers if there is some sort of a problem, or if they need to educate them on something, regarding the water line? You might think to yourself, have you ever heard from your water utility? Probably not, right? It's pretty uncommon, and that's one of their improvements there. Okay, so that's kind of the deal for the lead and copper rule. Some needed revisions there. Next, I want to talk about this Legionnaires outbreak. Turns out that Legionella, it's a bacteria. It's pretty naturally occurring, and it can make you sick with pneumonia. It can be pretty bad, and I'm borrowing slides that my wife prepared at the time. It's not actually person-to-person transmissible, though. It's almost never found to be the case that somebody contracted it from exposure to somebody else that had it. I'm sure there might be a way if you really tried, but generally the way it's transmitted is actually from a water source of some kind, whether that's a water cooling tower that's spraying aerosols, or it's aerosoled water coming from a contaminated shower, something like that. If the water, you kind of have to be breathing in a lot of aerosol water particles that contain the bacteria to get the infection. It was named Legionnaire's disease because there was, it's also known as Pontiac fever. It's endemic to a lot of places. Pontiac, Michigan, it's common in Michigan. So Pontiac, Michigan was one of the first locations. And it's called Legionnaires because there was a group of Legionnaires. I think that was some sort of athletic group activity, something. And there was a facility somewhere, and I think their shower water that was used in their showers was contaminated, so a bunch of them got sick. So it's a pneumonia, and it's serious enough that it gets tracked by the by disease surveillance systems. So a bit about public health. You've all been through recent shenanigans with public health stuff. So this is how it's kind of supposed to work for diseases that are important to track, or that we perceive as important to track. Let's say you get exposed to something, so you get sick. So then you go to a physician or a hospital. They are going to do some sort of diagnosis. Maybe that requires lab testing to see, okay, is this XYZ? Maybe they just know it already, and so they report it. Maybe they can test in-house. So if it's a reportable disease, that means they have to send some sort of indication ultimately to that will get to the surveillance system. Now, maybe that goes through a laboratory, maybe that goes through the local health department. Sometimes there might be some back and forth. Physician needs to know from the lab, okay, is this X disease? Is this cryptosporidium? If so, okay, the lab or the physician will then send that info along. So one way or the other, a state's surveillance system is supposed to catch that. Now, this is what I was talking about when I was describing my wife's role in monitoring at the Michigan Departments of Health and Human Services here. They were supposed to be getting information from the health department here, and it was supposed to be really flowing in both directions, right? It was supposed to be going back and forth from the local health department about Legionnaire's disease in particular, but the local health department really wasn't doing their job properly. So then at least the amount of data that would be sufficient to track where it's coming from, which is really all what epidemiology is about, right? We talked about the ghost map, the father of epidemiology there, John Snow. Ultimately, the point is to figure out where this is coming from and how to fix it, right? So that's why we do any of this disease tracking. That's why we care about this. So with them not doing their job, that was a problem. Okay, what did the actual outbreak look like? Well, we can take a look at some data here. I've got a few slides to show you. This one shows historically what typical legionellosis cases look like in a given year. And we see some historical years here, 2010, 2011, leading up to the outbreak in 2014, 2015. Typically in the summer months, you get a case or two per month, maybe 3. So we had 6 cases in 2010, 11 cases in 2011, 13 in 2012, 8 in 2013, and then 41 in 2014. So we can see that, typically we'll have some cases. It's naturally occurring, but boom. Just so happens that when did we switch to Flint water? Right here, right? So this coincides very well with that switch to the Flint River water. Suddenly there are 4 times the cases that they've been typically seeing here, and we'll see some data in a minute. The same trend happened in 2015 as well. So as they were trying to figure out, okay, where is this coming from? This is again the Genesee County here. What ultimately they came to was, hey, this is probably coming from a particular hospital. And here's the 2014 and 2015 data, by the way. So if you look down here, we've got 2014, 2015. We'll dig deeper into like what's going on at, what portion of these are where. But this is the kind of data that you get if you do the surveys well, is like, hey, okay, where is this patient? What waters have they been exposed to? All of that, yeah.
What percent of cases are reported?
Yeah, so what percent of cases are reported? It really depends on, like, when you say you have a case, it's a case that was diagnosed, right? So 100% of cases diagnosed should be reported according to the surveillance system. However, if you have a case, you just got sick and never went to the doctor, there's no reporting of that, right? So what you'll end up with is a scenario. I mean, and we kind of saw this with COVID. They tried to do this whole system with COVID. It's a bit foolish because for a variety of reasons. One is if you're trying to track the specific strain, but then it's changing, and that's making a meaningful impact on how things are happening. 2, it's so transmissible that even if you do find a source, what are you going to do about it? Is there any point to tracking it? Right? We don't track the common cold. We don't have flu as a reportable disease for the same reason. It's not practical. We also, during all the pandemic stuff, recognized that the flu reporting and flu tracking is, since it's not reported, it's not surveilled in this manner, they just use some mathematical models, right? And so when all of those cases that would normally perhaps be attributed, okay, some portion of these respiratory diseases must be flu, suddenly you take all of those and assign them according to whatever people are getting sick with. There's no baseline anymore, so we had no flu anymore. So there's some issues there. Definitely some room for corruption in terms of pharmaceutical companies wanting to sell you flu shots when young, healthy people probably never would need a flu shot. Listen to your doctor, but I'm not the type of doctor that helps people, so don't listen to me on that. Anyway, speaking of corruption, Hospital A here, I remember my wife telling me, yeah, this McLaren hospital is associated with a lot of these cases, and we know that, and it's a problem. We've got this outbreak and nobody even knows about it. It's probably in 2015 is when I heard about this. And but apparently the higher ups at MDHHS were buddy with the higher ups at the owner, the CEO, or whoever of McLaren Hospital. And so we're not allowed to say anything. So literally was like direct corruption there to try to keep the responsible parties off the hook. So fortunately, it eventually came out, and now we know this was McLaren Hospital. There's actually, I think, 2 hospitals that they were trying to do some comparison to. So Hospital A exposure here, and this is now public knowledge, but at the time it wasn't, and that was an issue. So let's take a little bit of a closer look. This is just taking the same data, and here they're, instead of cases of disease, so here are cases of disease, and I guess I'll expand on this for a moment. The red is Hospital A exposure. The blue is a resident on Flint River water, and the gray is not known to be either. Maybe they had some Flint River water exposure to, if they were living in the area or something, but at least they weren't living with it. So given that, there was some study of, okay, in this particular hospital, how is the hospital treating their water? Because a lot of hospital systems have a little bit more control over their water system, a little bit more in-house, given the amount of needs and the care they need to take for some of the pieces. So it tends to be the case that they will sometimes have to clean their internal distribution system a little better, I guess we'll say. So in this plot, we're taking a look at the percent of positive samples for some bacteria. And then, so that'll be the blue dashed lines and blue circles. In the black here, that's concentration, colony forming units per liter. So we can see some pretty high counts for bacteria. So point is, they were having some bacteria here, and so each time you have this black arrow, that's a hyperchlorination, so add a little extra chlorine. So in their practice, we can see this spike here, this kind of increase in bacteria. That's this is basically the summer of 2014 range. So they did try to treat it. They added a lot more chlorine. It helped a little bit, but it didn't really do any sort of permanent help. So they were actually supposed to be doing more than that, and eventually they, again, they had in 2015, all of this time, huge counts associating pretty clearly with Hospital A exposure here, and they weren't really properly treating their system to get rid of the problem. So we see finally, with this really large peak here in 2015, they finally did superheating with hyperchlorination. So they did super hot water plus chlorine, and then eventually did what they really should have done in the first place, is also add monochloramine as a residual chlorine addition. So we talked about using combined chlorine, so chloramines, as a way to give a low-grade disinfection long term. So they finally added a system that would dose that way and take care of it. So this is kind of goes to show that the change in the water system that happened right around this time seemed to have caused the hospital some issues. So changing to the Flint water created a condition where the hospital's own internal water management system was now having problems. They should have had better infrastructure, better cleaning protocols, and all of that in place anyway. So the hospital gets some blame here, but it also is attributable to that switch to the Flint River water. So it's another piece of the puzzle. Little bit more, this is just a kind of a table showing, the type of things that people were being asked. Okay, are you on the city of Flint water? Is it Flint Township? Is it some other municipal water? Are you on a private well? Do you know? And you can kind of see how some of this data was looking in 2015. So these would be cases, by the way, of the number of people sick or surveilled as positive. Here again, we see some comparison with no known hospital A exposure, some with. And so some of this was just the Flint River water, but certainly made worse by McLaren Hospital there. And as I mentioned, I don't think I have the numbers, but some of the cases here ultimately died of the pneumonia, right? So the Flint water crisis, goes beyond lead poisoning. All right. Any questions? Is that interesting? Okay. Yeah. So gotta take good care of our systems because people rely on them, right? All right. So that's all I've got for you today. Next time we'll get into kind of the background for wastewater treatment.